Okay, so let me start the today's discussion. Okay, so this is the week number 10 assignment we wanted to discuss in this particular session. So in this, what we have is in the first question, as it is shown that the voltage at the CP line, it is been given and you have to identify what is the state. So here the moment you have plus 12 volt, we know that it is a state A. Plus 6 volt, we know it is state C. When it is plus 9 volt, we know that it is state B. Plus 3 volt, we know that it is state D, and minus 12 volt, it is state uh, F, and 0 means state E. So accordingly, this particular answer number D is correct option. So you have to just select that. Then in the second question, given that the duty ratio of PWM cycle is 20%. So it is for the AC type 2 charging, and when the AC type 2 charging is happening, it's the EVAC which tells the EV that what is the maximum current which they can demand at that particular moment of time. So as per IEC 61851, it tells that your duty ratio is given as 20%, which indicates when you see from the table which was given in the lecture number 50 as well as in 49, it is comes under duty ratio greater than 10% to 85%. So your Imax will be nothing but 0.6 times of the duty ratio in percentage. So duty ratio is percentage 20%, and that is what we get the 12 ampere. So that is why 12 ampere is the correct option. Then in the second question, it is given that it is 45 ampere current which the EV can demand. So correspondingly, we have to find out the duty ratio, and then from the duty ratio, we need to find out what is the time during which the positive voltage level is been applied in one PWM cycle. So for that, we know that our Imax value given as 45 ampere. So again, it comes under the bracket of 10 to 85%. So our duty ratio will be nothing but 45 by 0.6, which is nothing but 75%. Now, once we have the 75% duty ratio, we have to then calculate duty ratio is nothing but T on by total time period of the PWM, which is 1 millisecond. So that is what we have done. So the answer is 750 microsecond, and the answer has to be written in microsecond. So it is just a 750 we have to write. Then comes your fourth question. In fourth question, the circuit was given to you. You have to find out what is the value you will get it at the PP pin. Now the voltage what you're getting at the PP pin is same as the voltage which you get on this particular point in point. So it is the resistor divided between R4 and the parallel combination of R5 and R6. So R6 is given, the moment it gets connected together, this point gets connected. So 4.7 will come in parallel with R6. So that is when you will see that you will get the R equivalent, which is parallel combination of 900 and 4700, which gives 755.36 ohm. And then from this, and then after that, what happens is that in this particular circuit, where we have R, this 4.7 kilo ohm comes in parallel with 900 ohm will be there. So you have to just calculate by doing the simple resistor divider, which gives the value nothing but 3.48 volt. So if you put those values, you will get the correct answer. Then comes the question number 5. In question number 5, the data is being given directly, the straightforward. You have to put the the formula. Your Lg is nothing but mu naught Ag n square by L. L value Ag value is given in centimeters square, so you have to convert it into meters. And then it is 100, it is 44 pi into 10 to the minus 7. That when you solve, you will get 12.56 micrometer, which was given in the question, that you have to calculate the air gap length in micrometer. So that is nothing but 12.56 value. Then comes the question number 6, in which you have to find out which one of the statements are the true. So in this, as we know that the moment we introduce air gap in the inductor, we can allow more number of current through the inductor. That means Ni, or number of turns multiplied by amperes, will become more, at which the core gets saturated, because our slope of the BH curve get reduced. So that is why we will get the value of Ni at a quite a larger value, at which the core will get saturated. Then the air gap in the inductor increases the inductance value. No, it is not correct. It will actually reduce the inductance value, because you have now just have the mu naught term. There is no mu r term which will come into picture. So, and mu naught is very much lesser than mu of core. So that is why air gap, you can say the inductance due to the air gap, insertion of air gap, gets reduced. Then the third point, air gap in inductor reduces the saturation flux density of the core material. No, it is a property of the core material. It is not gonna change the property. So that is not gonna, it will not, there is no change in that. And then the fourth point, the air gap in inductor makes the inductance value independence of core dimension. The answer is correct. Why? Because our reluctance will be nothing but Lg by mu naught Ag, and that implies my inductance is nothing but n square times n square by Rg, so which is nothing but L mu naught Ag n square by Lg. So nowhere in this expression of inductor your core dimension comes into picture. That is the beauty of insertion of air gap, that the moment you introduce the air gap, the core dimensions are independent of the the inductance value is independent of the core dimensions. Now there comes the thing, you may ask question, if there is no point of having a core, then core dimensions are not being considered, then why to have the core actually introduced? The reason why we have core, because it will direct the flux through through the uh, through the core itself. That means the Ag value, the air gap Ag value will be determined, and the Lg value will be determined only when you insert the core and having some air gap in between. So to actually determine this Lg and Ag value, you are introducing core in the inductor. So answer is A and D. Now the question number 7, the voltage level at,
Sir,
yeah, hello.
sir,
Huh?
sir, I have a small doubt.
Hmm. Please ask.
In core, if the air is hello, sir.
Hmm.
We in the core, the air gap should be cross sectional, or else like some hole also in between the core.
See, you can also have the material with the powder core. People can use the powder core, where what they do is they will take the ferrite, they will powder it up, and they will use the binder to make the core. So in that, air will get trapped into it. Okay, the moment the air will get trapped into it,
Okay.
you can say that it is the it is the core with the air gap. And again there, the thing is, they will define the Al value. They will define there's something called Al value. You have to see the Al
Okay.
value and then calculate what will be the number of turns you have to introduce to obtain the required inductance value, where Al value is nothing but they define millihenry per turns square, I mean per 1000 turns, like that they will mention. Every manufacturer will provide that. So what I'm trying to say is, the idea of insertion of air gap, it could be any air gap, is that the you do not want the inductance to be dependent on the core material. The moment you insert the air gap, your saturation, you are independent on the of the core material property, because core material property changes with the time, changes with the operation, or changes with the frequency of excitation. All those things it depends. Like your mu c of the core, your area of the core, your so area of cross section of the core, your length of the core, they may change it. So that is what this particular thing does that. You got my point?
Okay, sir.
Yeah, you can have that and still can be considered as the air gap is inserted. Then comes the question number 7. Question number 7, it is given that again it can be you can easily get it once you go through the lecture number 49. In this, the voltage level on the CP line is detected by the EVAC. So voltage level is actually changed by changed when the EV changes its S2 switch state, and that is why EVSC detects that voltage level and understands whether the EV is ready or not. So voltage level is detected on the EVSC side for the CP line, and the duty ratio and frequency is detected by the EV, because the duty ratio and frequency of the PWM is inserted by the oscillator which is placed on the EVSC side. So that is why the answer is B and C. Then question number 8, for AC type 2 charging, the CP is responsible for detection of correct plug and immobilize the vehicle. No, it's the PP. So it's the PP which is responsible for detecting and detecting this insertion of the charger plug and immobilize the vehicle. And CP is responsible to communicate the status of charging. So correct answer is C and D. In question number 9, again you have to find the two options. The CCS2, the communication is taking place over the CP and PE line. It is not happening over the DC minus and DC plus pin, so it is not correct. The CCS2, after the charger connector gets plugged in, the shutdown happens if there is incompatibility of EV and DC supplies detected. Yes, it is true. And in CCS2, the connector gets locked in once the compatibility is ensured and the voltage between DC plus and DC minus line is less than 60 volt. So yes, this is also correct. So option is ACD is correct option. Now in the CCS2 DC charging system, the moment the high level communication has to be done, then the CP over the CP line, the PWM of 3 to 7% is being implemented. So that means any value between 3 to 7, so that means 6 and 5 will come into picture, and that is why the answer B and D is correct. So this is all about assignment number 10. There are some doubts corresponding to that. So one doubt was the answer given is 750, but is answer is 750 microsecond. No, it is not correct, because you have to take 0.75. No, because the duty ratio there is always less than 1. So the duty ratio percentage will be, we have to do it multiplied by 100, but when you are writing D is nothing but T on by T period, because always T on will be less than T period. So this duty will always be less than 1. That means if it is a 75%, that indicates my duty to be considered when you are using this formula is nothing but 0.75, and that is when you will get T on to be nothing but 0.75 times 1 millisecond, which will give the value to be 750 microseconds. Now the second is you are mentioning different materials like books, journals, etc. Some of the book material we are not able to download. Can you share the content so that it will be useful for us? Yes, we are sharing the PPTs. PPTs are already been shared with all the lectures, corresponding to all the lectures. So please, the content has already been shared. Yes, we have informed the NPTEL office about assignment 8 and 9. I hope they will be done in this week or maybe coming next week. So those are the 3 doubts for corresponding to today's session. And in assignment number 11, so there is no numerical involved, but I think you have to go through the lectures to understand and fill out the particular options. You can easily go through it. You can be able to understand at what uh, state Slack is operating, at what layer Slack is happening, uh, how many frequency groups signals are being sent, in what layer the Slack procedure is done, in what layer SDP is done, in I mean how to identify which EBSU to be connected to. Then when the charging, I mean when the DC contactor gets closed in, and again these are the straightforward questions you have to you will get it once you go through the video lectures. So apart from this, if you have any doubt, please ask. Apart from this, because I think week number 11 is straightforward questions from the lectures, from the video lectures, so you can go through. So if you don't have any questions to ask, what we are going to do is we are gonna discuss this I mean the solution for week number 11 in the on the next weekend, where we will also discuss hints related to week 12, and the lectures for week 12 will be uploaded by so 2 lectures will upload by today, 3 more will be done in by Monday or Tuesday. That will be there. Yeah, so that is from my side. If you have any questions, you may please ask. Otherwise, we can end for today. I think no questions are been there. So maybe we will end for today.